Welcome back to our chemistry flipped classroom. And today we're talking about one of the final topics when it comes to stoichiometry, and that's the idea of percent yield. And when we talk about percent yield, what we're really talking about, this is not percent error. We've calculated that in labs before, but this is percent yield. And percent yield basically is a way of saying how much product was actually made in the lab versus the amount that theoretically could be made. And so we calculate it by putting the actual yield, which we measure, which we obtain in the lab, dividing it by theoretical yield, which is what we're going to calculate from stoichiometry, and multiplying it by 100% to get our percent yield. And percent yield tells us how close we were to making exactly how much we were supposed to make. How close were we to 100%? Reactions don't work perfectly. There can be experimental error. We might spill some, there might be some contamination, or sometimes there are side reactions, other things happening that aren't the target reaction. And so those errors are going to mean that the amount of product that we make in the lab is not always going to match the ideal amount that could have been made. So we need two things in order to calculate percent yield. We need actual yield and we need theoretical yield. So we're going to calculate theoretical yield using stoichiometry. This is the maximum amount of product that could be formed from the given amounts of the reactant. So we're going to use our stoichiometry to figure out how much in theory we could make if we used up all of our reactants. Actual yield is the amount that's actually made and recovered when we carry that reaction out in the laboratory. And so this is something that is either measured in the lab or in the case of many of the problems that we'll be working in class, will be given to you. So let's do a sample problem. In our sample problem, our chemist had enough material to make 75.0 grams of aspirin. However, he squandered some of the reactants for his own personal use. This is not a good idea. It's how you get fired from labs. And he actually only made 50 grams. So what was his percent yield? So we're going to take the actual yield, the 50.0 grams. We're going to divide it by the theoretical yield, 75.0 grams, and we're going to multiply by 100%. And we're going to find that this chemist made 66.7% yield. For aspirin, honestly, that's not a bad yield. However, that's another problem. So sometimes you'll be given actual and you'll be given theoretical and you're just asked to calculate percent. But more often, you're asked to calculate the theoretical yield. So now we have a stoichiometry problem. What is the theoretical yield if 5.50 grams of hydrogen react with nitrogen to form ammonia? And so in our stoichiometry problem, first thing we're going to do, as always, is balance our chemical equation. Oh, please ignore the fact that that's not where it's supposed to be. But we need 3 hydrogen, and we need a 2 in front of our ammonia here. And then that's going to balance our chemical equation. So we've balanced our chemical equation. Our given is 5.50 grams of hydrogen, and our unknown is, well, that's probably going to depend on what my actual is. So we're going to go to ammonia because we only have one product. So whenever we're doing a stoichiometry problem and it's a percent yield problem, we know that we're calculating our product. So we're going to begin with the given, and we are going to change the given into moles. So we're going to use the molar mass of hydrogen to convert to moles of hydrogen. Then we're going to use our molar ratio to determine the moles of unknown. And then we're going to use molar mass again to convert from moles of unknown to grams of unknown. And so we find that we have 30.9 grams of ammonia as our theoretical yield. Now, because I know this is not the end of my problem, I've left this 30.93 because I don't like to round until the end of the problem. If this were the end of the problem, I could only have 3 significant figures, but we're going to go ahead and leave this for now. Now we're also told that only 20.4 grams of ammonia is actually produced in the lab, and it asks us to find the percent yield. So the 20.4 grams is our actual yield. So we're going to put that on the top. The 30.9 grams of ammonia is the theoretical yield. So we're going to put that on the bottom, actual over theoretical, times 100%. And we get that we had a 65.96% yield. Now this really should only be 66.0 because I really only have 3 significant figures. Okay, so that's our quick overview of percent yield. We're just taking stoichiometry to one more step. As always, let me know if you have questions, and I look forward to seeing you and answering questions in class.